Greetings, building science enthusiasts, and welcome back to the Building Science Podcast. This episode is brought to you by Bowtex Systems, a Texas-based manufacturer of a high-performance insulated concrete wall system. Here on the Building Science Podcast, we stress the importance of the building enclosure to the overall comfort, health, safety, durability, and efficiency of our buildings. And you've also heard us say that the enclosure needs to do the heavy lifting. In fact, the enclosure may be the most important first decision you make on your next construction project. We believe that some of the best solutions for a high-performance building enclosure are monolithic mass wall assemblies, like the Bowtex wall system. Bowtex walls include structure, enclosure, and insulation all in one assembly, and is installed by a single trade. Manufactured locally here in Central Texas, fast to construct, and labor-friendly, Bowtex walls deliver competitive first costs and provide a lifetime of savings on energy and maintenance costs. Better buildings start with better walls. To learn more about how to design and build better buildings using Bowtex, go to bowtexsystems.com/building science. That's how they'll know that we sent you. That's BAUTEX systems.com/building science. Enjoy the episode.
Welcome to the Building Science Podcast. Welcome to the Building Science Podcast.
Bringing the human factor to construction, design, and architecture. Brought to you by Positive Energy in Austin, Texas.
Hello and welcome back to the Building Science Podcast. We are live at the Texas Society of Architects Convention, TXA 2017 here in Austin. And this is Christoph Irwin with Positive Energy here, as always, with my producer, Miguel.
Hey, guys.
Today we are talking to Darrell McMaster of Sustainable Homes in Boerne, Texas. I just got done a session where he presented. And after I swooned, I stood up and decided I'd like to try to get him for an interview. So without further ado, I'd like you to introduce yourself, Daryl.
My name is Darrell McMaster. I'm from Boerne, Texas. I'm a custom home builder. We build houses. Name of the company is Sustainable Homes. We design and build houses that run basically 100% off the environment. They run 100% on rainwater. They're net zero energy. So they're solar powered, geothermal. Wastewater is used on site. We're using it in the sprinklers. And we're also producing enough electricity to run the owner's electric car. So everything is coming from the house itself.
Awesome. The house of the future. So we're also here with one of Daryl's minions, Jacob Devora, architect. Go ahead and introduce yourself.
Not so much architect. I did graduate. Yes, I graduated from A&M in 2016, Texas A&M University, with a degree in architecture. I have minors in sustainable architecture and planning and another in environmental geosciences.
And you do hands-on work in the field.
Absolutely. Yeah. So awesome. Everything we have to do within the building process, I've been hands-on for the last year and a half.
And doing sustainable, generating all utilities on site. You're going to be a force of nature, my friend.
Thank you.
Your career. So the theme, we're doing a series of interviews at TXA this year, and the theme is going to be this idea of multiple dimensions of beauty, right? So we know that clients come to architects and they want the home to have certain characteristics that are considered beautiful, right? And of course, the program and the visuals of the building and the whole aesthetic, the architectural design aesthetic. But what we're doing at this conference today is we're trying to expand that, and we're just interview people and find out what their dimensions of beauty might be. So that's the first question to you, Daryl, is sort of along the lines of, your homes are beautiful to you. Why is that?
Well, I hope they're more than just beautiful to me. The customers themselves, they usually have them, So
good call.
I've been building houses. This is my 41st year of building houses. My family's been building houses just under 80 years. We've been built developments, custom houses from the West Coast to here in Texas. And so one of the things that we tried to change over in 2006 was we wanted to take our expertise that we had to separate us from other people and to take our expertise and some of the things that we saw what was going to be the future of home building. One of the things as far as architects go, we love architects to a certain point. And I know this is an architect show, and we're trying not to be
They're an
as
important
sensitive,
group.
sensitive to them, but a lot of times they are our biggest problem. One of the things that when we try to design a house, we're trying to look for orientation. We're looking for a number of things that try to make this house a performer. We're trying to build a Ferrari. And a lot of times...
In terms of performance.
In far as performance of the structure. And a lot of times the architects really don't think that. They're looking for appearance. They're looking for... I like to say a lot of times architects think they're Picasso. And so they're really not worried about material consumption. We'll get a set of plans and... a wall on one side, maybe 22 foot 6 inches. Well, for 41 years, I've been looking for the wood stretcher, and I haven't been able to find it. So what happens in reality is that we have to buy 24 feet of material. We get to cut that material off. The owner gets to pay for it. They get to pay us for the material, the labor to cut it off, the labor to throw it away. So we just think that when we can start to look a little bit different, take that beautiful concept and let's just start using material consumption and the cost of that material. If we can go back into a house and basically try to save money by use of material, can I then take that $5,000, $6,000, $8,000, whatever it is, and then convert that over to solar or whatever? For us, we're trying to get to the point where we are building houses that about a 48% return on investment of about 48 months. So that's really kind of the key to it. So the investment, does it cost more to put in rainwater, solar, the number of these things? The answer is, of course, yes. But when you can start to look at it, when you can eliminate the total cost, if you borrowed money, what would it cost you? And we have analysis. The average house we've run, you could be anywhere from $650 here in Central Texas, $650 to $750 a month for water, sewer, gas, electric, and the fuel for your car. If we can put that all into your house, and the increased cost is probably $40,000 to $50,000. If you've got to borrow that at today's interest rates, you're $150,000. So you're hundreds of dollars ahead. The return on investment comes back much quicker. And that's really what we're looking at is that our customers, they go from environmentalist to survivalist. What we call now is the economist. Hey, this is my last house, or we've got some millennials that are just coming up. If I can put the cost of my utilities and the fuel for my transportation into the cost of my mortgage, then that's what I want to be able to do.
I mean, economic levers move the world, and to be able to demonstrably shift from a low first cost optimized paradigm to a long-term cost, life cycle cost of ownership is huge. So that was what made me swoon, was recognizing that. So let's talk about, let's see, there's several things coming to mind. Let's talk about utilities. So you're basically creating the utilities on site. First, we'll list them, and then we'll go through them briefly. So could you list the functions that you're creating? I mean, I could think of them too, but you go for it.
So basically what seems to be the biggest eye catcher here and got most of our attention nationally is rainwater harvesting. So these houses run 100% on rainwater. We have no other source of water. We don't have a city meter. We don't have a well. They run on rainwater. So it takes a good design to understand, first of all, roof size, storage capacity, use that's inside the house. So there's just a lot that goes into the rainwater. Solar, we need to look at, what is the generation of this stuff. I can build an extremely efficient house, but if I have homeowners, I've got to realize that what we've learned is how they behave, behavioral patterns of people. I can put switches in rooms that will shut off after 15 minutes for motion, but there's also a switch on the bottom that can be left wide open. And if people go through and do that, it's human behavior and how to track and teach people at the same time. If you want a net zero energy house, we've designed it this way, but you've got to use common sense at the same time too. So.
The classic phrase is there's no such thing as a net zero home. There's such thing as a net zero home owner.
Yeah, that's a good way to look at it. But it's true. That's kind of funny.
Asset rating in some
right.
sense.
We have a number of houses. The great thing about our houses is these people love these things like crazy, and I get their electric bills on a regular basis. So I get monthly bills from houses that are from 2,000 square feet to 4,000 square feet, and it's -$4, it's -$10. A lot of them are used by co-ops, so they have a $22.50 fee that they're going to pay just for the right to have a meter, and we're below that. So we're using that side of it. It's just, and that's really the key to it, is people just, everybody's green then. They're green like $100 bills. So that's really kind of the key to it, is that when people see this, it's, geez, sign me up for that. So that's,
where do you capture your water? Where do you put it? Is it underground cisterns? Is it tanks?
Most of our systems are above ground. We have put a couple underground, just because return on investment. We're looking at the cost per gallon. So in the hill country where it's a lot of rock, we're trying not to dig holes or do whatever. We're trying to be above ground. Again, it's the cost per gallon.
That's rainwater collection. How do you make it potable? What do you need to do?
So basically, we have a system that we've devised over the years. It's like a 6-stage filtration system. So every time that it rains, we have a first flush. Mm-hmm. So we're going to dispose of the first 100 gallons. We want to be able to wash anything that's on the roof. The roofs are all metal roof. We found that, metal roof's going to clean the fastest, and not catch up with any kind of composition shingle. You're going to have oil in it. You've got all kinds of things that are built into it. The metal roof just washes much cleaner. Then we have 2 sets of filters going into the tank, so we want all the organic matter removed before it ever hits the water. From the tank, it then goes back through a 50 micron filter, a 5 micron charcoal filter, and a UV light, which then goes into the house, which is basically, the UV light will displace 100% of organic matter and the bacteria. So.
Fantastic. So you also, I guess, need to be mindful that there's not a lot of organic matter falling on the roof, or you have screens that filter that out. I'm thinking trees, leaves, things like that.
Yeah, what we're trying to do is in our filtration system, and when we design the house, we're talking to the homeowner. A lot of times we're trying to save trees. We think that trees are, first of all, they're worth a lot of money.
Oh, yeah.
Any kind of shade that's going against the house. When we look at heat sinks and how we're designing the house, we understand that our biggest heat sink here in Texas is the roof. Mm-hmm. Okay, so if we can get a tree to shade some of that, we're going to reduce the heat. It's the heat transference, which means that I've got to, air condition less. So those are the things that we're kind of looking for. We do have some houses, depending on the trees, they have some kind of leaf guard. A lot of times we found that it doesn't necessarily work. So we have in the tank, we have a filter sock that goes inside of it that catches any and all debris. So that's built in before the water ever hits the tank.
Very cool. Yeah. So the tree comment reminded me of somebody at a conference. It cracked me up, defining a tree as like a carbon sequestering, self-maintaining, self-replicating shading structure. And there were other benefits too, right? All right, so we've got potable water and we've got water collection. You're also using that water, I suppose, for other reasons, for like maintaining what landscaping there is, or how does that work?
So typically what we would do is that when people are going to look to landscape, so when rainwater is your only source of water, usage of that water is extremely important. So we really want people to pick native plants that are drought tolerant. And so that's really, we'll design in 6 months worth of water. You have a new transplanted plant. We're giving it 6 months worth of water. After 6 months, it should be to the point where it can live on its own and the amount of water that's there. With that, you're dealing with drip irrigation. In our irrigation systems, they have ground sensors that are in them. So if it rains for a day or two, basically the ground will tell us what's going on. Hey, we really don't need water. We have water that's still here. We do have water, as you know, in Texas, it can pour for 2 or 3 inches in a day. Well, you know what? We don't really need water, for a number of weeks potentially for these kind of plants. Again, it's grouping plants that if I'm in a planter that I know that the planter here basically they only need water every 3 days. And so that's really when it's in the design process of those plants, the use of those plants. A lot of times people will take a plant that needs water every 3 days and put it next to a plant that needs water every day. So what do? They dump all the water every day to each one of those. It's that design process, knowing what you're putting in the ground. It's just common sense stuff that Grandpa did for years.
Being smart all the way through. I know that to your comment about rainfall amounts, that Central Texas, surprisingly, has many of the record rainfall amounts in anything under 72 hours. Globally speaking, who got the most rain in a short period of time? We have a number of the top 20 events historically captured. Do you do gas or propane? Like propane backup, I guess, or did some of these off grid?
No, most of them are all grid tied. Believe it or not, again, we have environmentalists to survivalists. We do have some bomb shelters. To say that we don't, we do have that group, and we have generators and battery backups for certain customers.
In the zombie apocalypse?
Well, each one of them's got their own kind of funky. I didn't know there was so many scenarios for how the world was going to end, but pretty much I got them all, and I've got them covered. So now I've taken a little bit from everybody and whatever. It helps us, and the interesting thing is they'll allow us to try new things. We're always constantly. I raced boats for a lot of years, and so we were always doing research and development, and that's one of the things that we do with our houses is that we have different wall systems. So we'll go to a homeowner who has a west-facing wall, and we'll say, what we'd like to do here is build our standard wall, which is a 2x4. That has spray foam that's in it. The next wall over, we've got outsulation. The next wall over, we've got closed cell foam. We got a 2x6 wall. So we're going to be able to go back into these houses and then the same wall facing the same way. And we're going to be able to say, hey, this wall cost us $3.85, and here's what the temperature is. This one cost us $6.75. So again, it's always performance of the house. We're constantly looking for that performance of the house to make the house a better product. To basically, when we can make that work, then I can reduce the size of the solar array. For us here, what we've really learned is geothermal. We are firm believers in geothermal. Geothermal is 70% more efficient than any kind of other electric heat pump that's here used in the state. Not only that, but with our superheater, we're taking hot water off the coils of the machine, which is making the machine more efficient, put it into a storage tank, which is basically a water heater next to the original water heater. So every time that water heater, we have a demand in the house, someone wants to take a shower, it's not like I'm replenishing it with cold water, I'm replenishing it with water that's already 150 degrees. Again, so 7 to 9 months out of the year, I'm getting free hot water. Absolutely. Just every time that this machine is on.
So I agree with that completely, and obviously I need, since I'm a mechanical designer, we'll talk a little bit about ground source versus air source heat pumps. And technically in our climate, they're rejection heat pumps. We have usually roughly 2 to 1 where we're rejecting heat at the house, then capturing it. And one of the great things about some of the manufacturers, like Water Furnace, for instance, is that they do have these hydronic heads associated with their systems. Currently, on air source VRF systems, those exist in New Zealand, Australia, Japan, Europe, not here, right? And one of the things we're doing a session tomorrow is we have a petition on our website.
That's positiveenergy.pro/petition.
That is like, hey, manufacturers, we are the clients you say don't exist. Bring us the good stuff and we'll install it. So in terms of current draws and in terms of the infrastructure to create a ground-coupled heat exchanger, right, you'd have to do some math there because a good air source heat pump is pulling, the whole thing, an amp, nothing. And I didn't have to spend any money to dig a well. But this gets into something else that just blows me away about what you're doing is that, like Positive Energy, you're an entrepreneur, we're entrepreneurs. We don't have some deep-pocketed backer somewhere, or maybe you do.
No.
Okay. And so the point is, you are doing your own construction. So I noticed that Jacob's hands over there look like they've been working in the field. I mean, they're lovely hands. But
thanks.
So you've put together your own team, your own ecosystem to bring these houses to life. Is that right?
Yeah, so what we realized is that, again, you've got to make these things financially feasible.
Mm-hmm. And so you dig your own
wells.
Do
that, right. So that's kind of the key to it. So for us to do that, it's not like we go out and hire every sub. Mm-hmm. Most of the work we do in-house. Mm-hmm. We build cabinets because we couldn't find anybody who would sell us cabinets that have no urea formaldehyde in them. Mm-hmm. When we build a house that's basically a huge baggie that's airtight, I'm concerned about the kind of paints, the floors. All of our houses have ERVs in them, so we're exchanging the air. We're concerned about inside air quality, not just outside. We want to bring that outside into the inside. So we want to we're concerned about how the house is basically going to live, how people are going to live, and we're not concerned about, hey, we did this and we're down the road. We want this stuff to actually We want it to be Ferraris. I mean, that's what we're trying to do.
Awesome.
And if you got some guys that'll bring us some kind of new heat pump, we got definitely customers who'll try them. So,
Well, I love the way that
it's
you're
we'll
data
try
driven.
it. So,
The fact that you're data driven, numbers based, I'm with you on that. Let's make it work. And it is the case that if you want to, have really good hot water production right now based on heat rejection during cooling mode, you got to go with what exists. So what's huge in what you just said is that, fundamentally, let's say the big performance metrics, like someone approaches their house and they say, what makes my house awesome, right? So they'll say, of course, it's the architectural design, it's the program, the floor plan, how it looks, how it feels. And then, maybe ever since the 70s or since Al Gore's first movie and now his second movie, it's been the energy performance, right? So eclipsed by all those, or both of those, often is, what about the people, right? What about thermal comfort? What about indoor air quality, indoor light quality, sound, odor, vibration? All these human factors, they should have equal footing. And what you just mentioned about the ERV, right? So we're firm believers or advocates saying, look, if there's people in the house, you're ventilating the house, right? That's the way it is. And if it's an energy penalty, that's fine because it's pro-human.
Yeah.
It's, and I've actually heard a lot of people, certainly around this region of the country, where it's hot and humid outside, and it is an energy penalty to bring in ventilation. So hats off to you there. You don't really use gas and propane, is that right?
Well, typically we wouldn't want to do that. Again, what we call our houses...
Right, because they don't go off grid.
Right, so we call them point source houses. So everything is generated at that point. So for us to go and buy a utility when we are a generation station, that doesn't make really sense. Do we put in propane tanks? We do. We have people that have natural gas. I have to cook with this. My wife won't do this. Okay, I'll work with you. I don't make it doesn't make any sense to me. You have a solar array that now, and so you're dealing right.
Yeah.
So have appliances have changed. My wife's the same way. I have propane in my house. She'll only cook with gas.
Right.
And now over the last few years, she's been able to see some of the improvements in cooking that's now come out with electric, so that,
Electric resistive or induction?
both, so it's just one of those things that they're much better than what it used to be. Mm-hmm. And so she's willing to say, okay, let's go ahead and give it a try, because we bought so many of them. She handles all that stuff with the clients, so she's absolutely out there all the time.
Beautiful.
She sees all the newest stuff, so she can come home and say, hey, this is what's out there. Where most trade shows where appliances are out, because she'll spend the days just, what do you got? What's coming my way? Because she knows I'm only going to give her so much power. I don't care what this does. You're only getting so much power over here to do this. Figure out a way to make this happen. Convince these people this is what they need. But back to the gas and the propane. The only time that we've ever used natural gas, sometimes at barbecues, but we have also, years ago, we stuck in a fill station. So basically it's the same kind of thing with an electric car. You have an electric car charger, but they have natural gas stations. So you have one that's in your garage. It's just an appliance. So instead of using electricity, we have so much natural gas here in Texas. Anybody who has natural gas should have a fill station in their garage. Beautiful. It is the most efficient way. It is the cleanest running car. It's 25 cents a gallon. Seriously, you go out in the corner over here and it's $2.50 to whatever. The comparison wise, the amount of performance, the longevity of the motors with natural gas. We should, in the state of Texas, everything should pick and run on natural gas. It's coming out of the grounds. We've got so much of it, it's just unbelievable.
Well said. So a fill station, just to help people understand they're listening, is you're filling your car, in a conventional car, it's fuel tank with natural gas that you store on your property. Is that right?
Well, no, what it is that you have natural gas, so you're getting it from the utility, and just like your dryer or whatever, it is a box that goes on the wall. And Austin Energy one time had some of the fill stations that they were using. They had a Honda Civic that ran on natural gas. So you can get them, and what happens is it's a slow charge. So if your car's empty and you have I think with those Hondas were, 12-gallon tanks on them. Mm-hmm. And it took probably 7 hours. So you come home, your car is empty, you just went in there, you plugged it in, and it's slowly charged. So you had natural gas, and it was coming just like the same thing with the electric cars, how you come home in your garage, and it's about the same size as what an electric car charger is. It's about, but it's just natural gas. So
that's so beautiful. Yeah, so this dovetails into previous podcast episodes where we talk about exergy efficiency, where a natural gas molecule burns at 3,500 degrees Fahrenheit. One of The silliest things you could do with it is use a 3,500 degree heat source, which is an industrial, like a process grade heat source, to bring water to 140, 120 degrees, or to bring air to 70 degrees. It's just ridiculous, right? And when you look at natural gas, you think about it, well, what is it about natural gas? It's in the molecule, right? It's in the degrees of freedom of that natural gas molecule, and it's this very high energy density, lightweight fuel source. So if someone says to you, I have this fuel that is high energy density and lightweight, what should I use it for? The first thing you're going to say is mobile applications where I need energy, right? The last thing you're going to say is for my water heater, for my furnace.
Right.
So we get along on that. So electricity, right? This is obviously the big one in the room. You are using PV, I imagine?
Yes.
Some wind as well? Have you done that?
No, we've looked at wind, and really, unless you're in West Texas, it just really doesn't make the return on investment is just it's Fantasy Island. For a number of years, and we haven't checked
Even the vertical
recently.
axis
We haven't checked recently. So if you go back, let's go back 7 years, 8 years. You and I could have started a wind machine company. Okay, we could have said this thing will do double backflips. It'll do 40 kilowatt hours a day, and there was no regulation. It was no nothing. Come to find out, it did 4. Okay, so people were buying these things, hook, line, and sinker. They just got them up to the side of the boat. They gaffed them. Oh, yeah, I've got enough wind. And what was happening is that I can't tell you the number of times that I've spoke throughout Texas. And when I explained that to people, someone would come up afterwards, wish I'd have met you a year ago because I just spent $40,000 on these wind machines, and 4 solar panels are getting more electricity than what these wind machines are. So again, it's location when it comes to wind. So basically everything we're doing here, because you're dealing with homeowners associations, you're dealing with a number of government agencies trying to convince them that, hey, look at this really is the right way to go. And, when they're concerned about, hey, we just want, take 2 acres of grass and we want it all to be green and we don't want to see your rainwater tank. And there's an individual by the name of John Kite out of Boerne, Texas, who has been instrumental in writing some of the rules and the new laws for the state of Texas when it comes to rainwater. State of Colorado, it's illegal to collect the rain that hits your roof. So it belongs to the state. You can't touch it. So we're really fortunate we're where we are. It's just a number of things that people need to start to take a look at. Again, everything for us is water. I can create more electricity. I can't create more water.
I like it. Okay, so the wind thing, though, I hear you in terms of what's available. But I think, like on a large level, as a global society of beings that need energy, we need to recognize that the atmosphere is trillions, don't trivialize that, trillions of tons of gases held to the Earth's surface by gravity, and it's moving like this slow-moving river. The amount of energy in like a cold front is, dozens of atomic bombs worth of energy. So I think as a society we need to learn to go after it. And I do agree that on a micro scale, and actually that reminds me of jumping back to gas. So microcode generation has been, always like talked about as this, next great frontier where you get this like a refrigerator-sized device that you run in the gas out of one side and electricity for your house comes out the other side. Have you looked into that?
We did. And this is the interesting thing is it's here in Texas we would say this is not my first rodeo. We have pretty much seen everything. When we first went to the first solar show that was here in the United States, International Solar, it was in Long Beach, and there was maybe 2,000 people. We were there last year in, I think it was in Las Vegas, and there was 100 and some thousand. Tremendous growth in the whole industry. The industry's changed because originally it was designed for PV for houses, and now it's almost gone entirely for utility. So that's just one of the things that we're looking at. So we've seen most people, we've talked to a lot of people that you have something, it's kind of like you were saying, you got a product, I'll try it. Okay, just heads up, if it's a dog, we're going to tell you, hey, this thing's a St. Bernard. It doesn't work, it doesn't do whatever. I can't tell you the number of products in the last 11 years that we've seen that's just like, man, you guys get off the crack pipe. It just doesn't work at all. But it's they had a good marketing deal, so that's just kind of like, okay, let's get back from Fantasy Island. Here's reality. Okay, so I've got to sell it to Harvey and Harriet homeowners.
So you've tried it and it didn't work. Or you looked at the math and it didn't.
Well, yeah, it just didn't.
Okay. So it's interesting, though, that whole concept of basically using our homeowners, using our homeowners as an uncontrolled experimental set, right? Like, it happens hugely in air quality. Like, let's put this brominated flame retardant in the air. Wonder if that'll be a bad thing. We'll know in a few dozen years. And who's the laboratory rats? Us, right? It's just nuts, and we acquiesce to that because we don't realize it. But I'm old enough to remember wearing pajamas that my younger cousins were having all their pajamas thrown away because they had these flame retardants in them. And I'm at the age where I'm done wearing pajamas. I'm like, oh, really? So I was wearing those all those years, the pajamas with the little feet in them and stuff. All right, so PV, on-site power production is PV. Are you doing storage as well in your project?
Some of the houses we are doing storage. I'll be honest with you, storage is the real key. Anybody who's been in this industry long enough, there are some people out there that make cars who make a big splash. They're kind of good for the industry, but in reality, some of the stuff that's been brought out, it'll turn a fan on. I mean, a ceiling fan, and they're trying to say, hey, for $7,000, we'll put this here, bolt it on your wall, and it'll run your house. Okay, it's nowhere near
fantasy. I agree.
It's just so storage is really.
It does get the message.
Oh
out.
yeah, so there is
a
tremendous amount of bling, but those people see that stuff and they see it on CNBC or they see it in a magazine and they come to you. Oh, but the magazine said. It's like, okay, that's just not reality. Here's reality.
So the BIPVs too, the building integrated PVs, the solar shingles. That's another.
That's another one of those things. And so what happens is that
coming attractions.
It's a great idea, but here's the thing: is that, like I said, we've been doing this so long. This didn't come up. Okay, back in 10, 12 years ago. If it was Arizona State or the University of Arizona, they were working in conjunction with a number of roofing manufacturers trying to build composition shingle roofs that would do basically the same thing. Now, if it was such a great thing, it wouldn't have disappeared. So obviously it didn't work. If you read real close, and the guy who wrote an article about the roofing you're talking about was realistic, and I appreciated that. It's like, okay, well, if your roof cost $150,000 to put on, then yeah, this might be financially feasible. The truth is that when you have a composition shingle roof, and say you're in Texas on a 3,000 square foot house, that house is, it might cost you $15,000 to $18,000. A metal roof is probably going to cost you $18,000 to $24,000. Nowhere near $150,000, $140,000. For that, I can do whatever you want to do. Net zero energy, I can power your whole neighborhood. We'll put a CPVC panel in the back here, and we'll light up the whole neighborhood. So, and that's really kind of the key, is that, we've been doing this a long time, and I could have built you a net zero energy house 20 years ago. I could have put a small nuclear reactor in your backyard, and you could have said, hey, we're net zero energy. Conservation is the key to what we do. Conservation far exceeds creation. Beautiful. To us, it's a 3-to-1. So if you're going to give me $30,000 in creation of new power, you give me $10,000 for an existing house, and listen, we'll go ahead and we're going to change your windows. We're going to do a complete eval of what you're doing. What can we do to make that happen, to bring down the cost of what the solar array was going to generate? So those beautiful. Are the kind of things that we're looking to.
Conservation exceeds creation.
Yeah, conservation far exceeds creation.
That's beautiful. So we've said that on the podcast, that the enclosure does the heavy lifting. It's the gift that keeps on giving. You design it once, it's a stable, durable asset. Yeah,
right.
Huge, beautiful. So batteries. Just want to comment that what's happening in seemingly an unrelated industry is that the car companies, the auto manufacturers. Let's say that Jacob and Miguel here are hipsters, because you both kind of have that generation.
Oh, thanks.
You guys are more functional oriented, and so what's happening is the car company's profit is actually not on the base car, but it's on those luxury upgrades. And so people are starting to buy less and less of those luxury upgrades. So the car companies are going, all right, what's our big play? And so one of the it's in energy storage. First for portable energy storage for transportation, but they're recognizing that over the long term, the global society right now is going off of fuels onto technology to power itself. And that means from fuel to technology, you need storage in the equation, and you need batteries, and you need to solve this battery storage problem. So the big oil majors and the big auto manufacturers, for whom an industry like PV or battery storage is a little blip on their spreadsheet, right? They're starting to turn their super tanker, kind of howitzer kind of gun toward battery storage. So it's okay with me that like a Tesla is, if you're a Tesla buyer today, if you're fully aware and fully conscious, you're going to go, I am subsidizing the advancement of this high-performance electric vehicle industry. And this car is not the be-all, end-all where it's going to go, but this is the best that's available now. And it's a very similar way, that's what's happening, in my opinion, with house-level storage systems. And so I think you and I, as advocates for this and as technicians or designers that choose these systems, we need to stay connected and we need to stay on it. I think we're running out of time. And I just wanted to wrap up by getting again into the business side of things. So, Jacob, what is your role, and how many of you are there with working with Daryl?
Well, I've started to work for Daryl about a year and a half ago, and within the last year and a half, you name it, if it has to deal with the process of building a home, I've done it. I've been in the concrete hole, pouring concrete at 4 a.m, to being on the roof, hooking the panels together themselves. Within the last year, I've been blessed with the opportunity to just truly get fully engaged and truly learn, and not just designing the home on the orientation and why it should do this, but actually being the one nailing the walls together and actually putting it there. So yeah, to answer your question, there are not many of others like myself and the company, but there are a few. And so we are growing, and it's just a matter of trying to not just so much get the job done at the end of the day, but teach and grow within the industry itself. Of when we walk on job sites in full brand new neighborhoods, and there are 4 or 5 different construction firms there, everyone has their own team, and you start talking at lunch and guys are like, well, why are y'all doing that? And then when you start actually engaging in the conversation, so much of our own industry doesn't even understand what's going on. And that's by far...
Say that one again. So much of our own
so many people in our own industry truly not just...
They just assume it's fine.
Yeah, exactly. And then once you fully start breaking down each individual thing that we do and why we do it, everyone's heads start to turn at that point. And then people are like, oh, well, y'all's houses must be to the moon with the price, and that must be so expensive and just unrealistic. And then when you actually break down the numbers at the end of the day, you're breaking down the life cycle cost numbers too. That's exactly. Cost of ownership numbers. Yeah, I mean, when you break it down,
the actual numbers.
Yeah, exactly. The actual numbers, the actual green in the situation, you really truly can't beat a house with an ROI of 48 months.
Yeah, that's awesome. So we're getting toward the end here. Daryl, any final comments?
Yeah, I just, thanks for the opportunity. It's kind of unusual to see a place like this where we're dealing with people, with architects, because they're definitely not the average person that we see as looking forward to what we do. A lot of times they're the people who are fighting against us and trying to say, well, why would we do that? Let's just... let's put more crown molding on. Let's put more granite counters. Let's do this and that. And to us, it's a matter of, okay, your total utility cost is $700-800 a month versus $150. Mm-hmm. And I think that when people start to see that, and it's education, it's how do we educate the people? How do we do that? I'm thankful for Jacob, and Jacob graduates from A&M, and he has to physically work. I mean, it's one of the things that we do, and it's been hard. I'm sure that he's been sitting out there and thinking, geez, I got a college degree and I'm doing this. And so he's fortunate he understands the long-term deal of this. I mean, one of the things that I sit down with new guys is it's kind of like the movie The Karate Kid. There's a wax on and there's a wax off. There's a reason that we're doing this stuff, and so you may not see it today. You may think that I'm absolutely a slave driver or I'm a knucklehead or whatever it is. There's got to be an easier way to make a living than doing this. It's that long term of being able to say, hey, there's a whole picture here, and unless you can see that picture, unless you have the vision for that, and a willingness to get to that point. And that's where we think the construction industry is going to go to. We need people like this who are going to say, we can do more than one thing. We call them crossovers. You're going to be able to do solar. You're going to be able to do some of the rainwater. You're going to be able to understand the geothermal, a number of the systems that are built into this house. And so that's what we've done, is we've designed basically a different building format that my family came from, which was go out and we hired all the subs to do it, and that's how we did it, versus now it's all in-house. So we're trying to keep as much of that as possible.
Beautiful. Well said. Well, thank you both. My very final comment, it has to do with this low first cost orientation. One of the things it's done, your last comment there about crossover trades and crossover expertise is quite real, is we rely on exploited, either mildly or significantly exploited labor in our delivery of conditioned space to ourselves. And one of the ways we can keep that going is the labor is interchangeable. And why it's interchangeable is because it's not really that well trained. It doesn't have that much expertise, and that's a shame that the hands that do the work are not where the expertise resides. I guess we're going to call that a wrap, and I think maybe there's a part 2 hidden here somewhere. Thank you, gentlemen, very much. Darrell McMaster, Jacob DeVore, thank you so much.
And big thanks to Bautex and to the Texas Society of Architects
for sponsoring this. Yeah, thank you guys.
Podcast. This episode is brought to you by Bautex Systems, a Texas-based manufacturer of a high-performance insulated concrete wall system. Here on the Building Science Podcast, we stress the importance of the building enclosure to the overall comfort, health, safety, durability, and efficiency of our buildings. And you've also heard us say that the enclosure needs to do the heavy lifting. In fact, the enclosure may be the most important first decision you make on your next construction project. We believe that some of the best solutions for a high-performance building enclosure are monolithic mass wall assemblies, like the Bautex wall system. Bautex walls include structure, enclosure, and insulation all in one assembly, and is installed by a single trade. Manufactured locally here in Central Texas, fast to construct, and labor-friendly, Bautex walls deliver competitive first costs and provide a lifetime of savings on energy and maintenance costs. Better buildings start with better walls. To learn more about how to design and build better buildings using Bautex, go to bautexsystems.com/building science. That's how they'll know that we sent you. That's BAUTEX systems.com/building science.